Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 33. So the last two tutorials, we went through how to build some games with advanced Glimmer DSL for SWT concepts, such as custom widgets and custom shapes. Today we're going to go through yet another game, so it's going to be another elaborate sample, Tetris. And this time we're going to follow a different approach in looking into the code of the game. We're going to do a top-down approach instead. So we'll think of it from the view level first, and then we'll dig down into the model level, the model layer. So let's get started by presenting the game first. So Tetris is a very popular game. It became even more popular in the 90s during the Nintendo Game Boy era. In any case, let's activate this game so it's actually paused. So I'm gonna activate it and then let's start playing. The goal of the game is to basically build up lines using shapes, and for every line you build up, you actually score. And every time you cross 10 lines, you basically go up a level in the game. And whenever you go up a level, the game becomes faster and more difficult. So let's try to build a line. So I almost have a line at the bottom. You can see it here. I'm missing 3 pieces over here. So let's see if we can get it built up soon. So I'm going to keep adding pieces over here, and usually you want to try to add pieces in a way that would pave the way for future lines. So let's keep trying to do that, and we don't want to basically have gaps. The more gaps we have, the more difficult it is to build lines, and you'll see that soon enough. Okay, there you go. So I can now take this, and in this version of the game, it's basically advanced enough to handle you moving the piece right at the very last moment in order to plug it in. There you go. You just saw that. So we're only missing one basically block in order to build the bottom line. So let's keep trying. And by the way, the way this game is built is it basically has difficulties. So right now the pieces are moving at a kind of a slow pace. So if you were to look at the top menu, we have a speed menu over here. You can see it over here, and we're actually at this easiest difficulty, the speed of a snail. So I can, for example, advance to the speed of, let's just say, a horse. Okay, you can see now how the pieces are moving much faster. So that will get us to play a faster game. And I'm still waiting for the one piece that would plug that line at the bottom and give us hopefully 3 lines. So it's basically the blue piece, the light blue piece. So I'm going to keep waiting for it. Okay, so this is a move that I got forced to do, and you can see I ended up with a gap, a white gap over here. This is usually not the goal of the game, but if it happens, it happens. You just have to deal with it. But there you go. We just got the light blue piece, the line, and boom, I just scored 3 lines. So I every time you score a line, it gets eliminated from the game pieces. That's exactly what happened. So hopefully we're doing much better now. So I have one more thing I could do is actually if I hit down, it speeds up the pace of moving the pieces. So if I'm sure I want to land it here, I can just hit down. It'll move it faster. So I can hit this down like that. I can hit this down like that. See, it moved it faster. Boom, boom. That was pretty good. So we're about 9 lines. We built up 9 lines. So that means I need one more line in order to advance a level. So let's keep at it. I'm just trying to demonstrate a full game that includes losing at the end. And given that I changed the speed level of the game to a horse, it's going to be a much more difficult game than normally. So hopefully it'll be a quick game. But as you can see, the L piece is a very, or not L, sorry, the I piece, the line, that blue line, is a rare piece that's very valuable sometimes. So see here, I'm going to be able to build up 4 lines at the same time, and that's the biggest scoring move you can make in this game. So so far so good. The gaps are gone. We've cleaned up the board. It's looking much better. So This is hopefully going to be a very quick game. Well, I mean, given that things are going so well, it's probably going to take a long time before we lose. So I'm going to just go here and go ahead and make the game more difficult. Let's try Gazelle. Oh, wow. That's faster. Faster for sure. It's so fast that I don't need to push the pieces down quickly, like I mentioned earlier. Okay, let's push this quickly. Let's push this quickly. And by the way, one other thing I didn't demonstrate or explain is basically the buttons of the game. So you can hit left and right on the keyboard to move the pieces left and right. And then you can hit the left shift and right shift to rotate them. And there are other extra buttons that you can use instead as alternatives, but these are the most basic buttons of the game, is the right shift, left shift, and then right and left. So usually you're moving pieces right or left, or you're rotating them right and rotating them left. And if I press down, wow, it's just become much faster because I reached level 3 at the Gazelle level, so it's a much tougher game now. But basically, you can hit down also in order to speed up the pieces further. And if you hit up, that button is configurable. For example, you can see it here, up arrow, instant down, right, rotate right. We'll take a look at it in a moment, but as you can see, I just reached a game over state, and it basically gave me the score. It kept track of the score, the number of lines eliminated, and the level that I reached. So here I can just type in my name. So I played the game like 8 times before, so there we go. So then I hit enter. I can scroll down this list just to see other scores, and then I can play again. And that starts a new game. For the sake of keeping the game simple to explain it, I'm gonna make it easy this time. So the key thing is the up arrow is configurable. So I can configure it to rotate me left. So that's useful if you want to only use one hand, because the right shift button will rotate right, and it's right above the up arrow. And then I can use the up arrow to rotate left. So right shift, up arrow. So that way I can play the game in one hand actually. I don't need both hands anymore. So I don't need to use the left shift button. Though to be honest, I prefer to use it. The game makes more sense to my brain when I play it that way. But one more interesting feature is this instant down. I can make it an instant down instead. So if I do down, it just pushes the piece slowly. I mean, it pushes it faster than normal, down, like that. There you go, like that. But if you're absolutely sure about where you're landing the piece, you can hit up, and it gives me instant down now, because I configured it differently. So there you go, instant down. So that way you can play a much faster game when you're at an easy level. So that's pretty much it. There's this feature beeping. It might be difficult to hear it through this video, but basically on every line eliminated, we get a beep. So let's see if we can hear it on the next elimination. I'm trying to bump up the volume to see if that helps. There you go. That was a beep. So there is a bit of a sound element in the game, and of course I could disable beeping if I don't like it. So there you go, it didn't beep. So yeah, that's pretty much it about this game. Oh yeah, I can show the next block preview in order to make the game easier, or I can hide it. So see this next here, which shows us the next piece, is hidden now. So the game now is more surprising and difficult. Like I have no idea what piece is coming next. So that adds a bit of complexity to the game, or a bit of difficulty, sorry. But I can make it easy again by enabling this feature. So now I know there's a blue L-shaped piece coming next. There we go. There you go. So there's a red one coming next. There it is. So that makes the game a little more predictable and easier. Finally, here in the menu, I can show the high scores in the middle of the game. That pauses the game automatically. Then I can close them. I can pause the game. I can have it continue, and I can restart it. I think I pretty much covered everything except help. Help will just give us an about message about the game. And that's pretty much it. There are shortcuts, by the way, that I have configured. They're called accelerators in SWT, but basically what that means is I can hit Command-Shift-H, and that will give me the high scores. Boom. I can hit Command-P, and that pauses the game. I can hit Command-R, and that restarts the game. So there you go. It's a very fully featured game. So let's start diving into the code. So I'm going to pause it and move this to the left side, and let's start looking at the code. So in the very first tutorial, I gave a very quick preview of Tetris as an advanced example of using Glimmer DSL for SWT. And the key thing that I highlighted was if you look at the body of the app, it's a very short body, and it maps directly to what we see on the screen. So that way we keep the code, what you see is what you get. So it's very simple. We have a shell, meaning a window that's non-resizable, and it's got a few properties like title, minimum size, image. Image is just the icon, meaning if I Command Tab, I can see an icon here for the app. And then finally, there's a Tetris menu bar. You saw that at the top. There's a play field, which is this area. And then there's a score lane, which is this lane that displays scoring information. And that's pretty much it. This is the whole game. So again, as long as you keep your code as simple as possible by mapping to the highest level concepts possible in the body of the app, you make the maintenance of the code very, very quick and simple. So next, what we want to do is dig into every concept specifically to look at their body. But basically, the Tetris menu bar keyword here is a custom keyword representing, a special custom widget we built that was representing the menu bar of this game. Play field is a custom widget, and score lane is a custom widget. So these are all custom concepts, and you can, again, they're like first-class citizens now of the Glimmer GUI DSL. So you can specify them in the body declaratively, just like you would specify shell or any other widget that is built into SWT. So let's look a bit more at the code now. Let's get back to the beginning of the class. So it is a custom shell, meaning a custom window, meaning an app. It has a few constants over here. It has a configurable play field width and height. So by default, Tetris will basically Tetris games generally are 20 blocks in height and 10 blocks in width. So these are the defaults that I have configured here, which are getting pulled from the game model. We have a game model attribute, and before building the body, we're basically building a bunch of objects. There's a bit of multi-threading in the code, so that's why I have a mutex. But here we have the game model. That's the most important thing in representing the concepts and rules of the game. So Glimmer Tetris is built following the MVC pattern, model view controller pattern in general, but it's also a hybrid of that plus MVP, which is model view presenter. Either way, what that means though is a separation of concerns between the game rules, which are in the model, and they don't care at all about concepts relating to the view, meaning they don't care about any widget names in SWT. They're not even aware of them. They're just focusing on the model of the game. And then we have the view part, which is just the widgets and the GUI DSL and how to represent all of those gaming concepts visually. So that enables a very clean separation of concerns, and it makes the code very, very maintainable. And in fact, you can put one software engineer on the model layer to program all the rules of the game, and they might be, like advanced AI software engineers that know about machine learning and stuff, and maybe they want to code an AI in the game that uses machine learning. Either way, they can work independently of the Vue developers as long as they follow an API that the Vue expects, and that's pretty much it. But again, I mean, even you as the same software engineer, you would benefit from this approach as well, because it makes the code very highly maintainable, because anything you see in the view is just view code, and anything you see in the model is just more logic code, like game rules and stuff like that. So let's dig further into what's happening here. Here we're just configuring the beeper of the game, meaning every time it calls beep, what beeps. So you can configure an MP3 file to fire up, every time, or a wave file. In this case, I just used a built-in feature in SWT that lets you have a beep on the display. This is kind of like old computers that used to beep whenever there's an error. So you have access to this feature in SWT. So I just configured that as the beeper. And then here for the display object, which is a singleton in SWT that represents your displays, your monitor, you can configure an app name. So I just configured Glimmer Tetris. This is not really necessary if you package this app as its own Mac app or Windows or Linux app, like a Windows MSI installer or a Linux Debian or RPM installer, because they will handle this detail automatically for you. But anyways, I chose to configure it here, but it's not really necessary. You can ignore that line. Anyways, this is the display singleton that represents the screen. And one thing that's special about this game, as opposed to other games, is that when you're making moves, you are nowhere specifically on the screen. So your access to the events that will make the moves in the game is global. Meaning if I hit right, there's no focus. Unlike like standard desktop apps that have a focus on a widget, here there's no focus. Basically, if I hit the right button anywhere without focusing on a part of the screen, it should move that piece, the tetromino block. And these are called tetromino blocks, by the way. So anyways, that means that we want to catch the event at the display level, at the global level, and not necessarily at a widget level. And that's why in this game, what's special is that I'm hooking the keyboard down event on the display itself, which hooks it globally. And that means, and then whenever a keyboard button is pressed, we get a key event, and if it's a key down, an arrow down, we're gonna tell the game model move down. So the game model will handle everything for us, and that's what I wanted to talk about here. Is we're gonna follow a top-down approach instead of like the last two tutorials. So the game model in this case is gonna be handling everything for us. It'll abstract everything. So in a sense, it's kind of like a presenter or a controller. But basically here we're saying, okay, do the down action if we hit the down arrow. And this is just here rate limiting for Windows and Linux where it's needed. On the Mac it's not needed, but let's not worry about this. If we hit the up arrow, then we check the options that we set on whether we want instant down, rotate right or rotate left, and then we invoke that option on the model. If we go left, we tell the game go left. If we go right, we tell it to go right. If we shift or alt and hit the right shift button or alt button, it'll rotate right, otherwise it'll rotate left. And that's pretty much it. By the way, here for the up arrow, we could have delegated those details completely to the model or controller and had it handle the case statement. We shouldn't have had to handle it at the view level. But I mean, you could always improve. Like this code is a pretty good start, but you can always improve further. And this is one improvement that I just thought about, is all of those details could be pushed down to the model, and that would be more of a ask, don't tell approach or whatever. So, or tell, don't ask, whatever that principle was. But either way, here we have an on, about, and on quit. So on the Mac only, you usually get an about and a quit actions. So I just configured them to do something. But on Windows and Linux, you also get this exit action menu item. So you can use that in order to exit the game. After body usually contains things you want to do after you've constructed the AI. I tend to use it to observe the model and make changes on the view level. When different changes happen at the model. So this is kind of like following MVC in the sense that the view observes the model, and when the model changes, the view updates itself. This is useful for certain things. It's useful, for example, for displaying dialogues. Like in this case, on game over, we display the game over dialogue. And then if the game over changes again to false, then we start moving tetrominos down again. And here we say, okay, check the show high scores attribute on the model, and if it got set, then show the high score dialog. So that's what happens when I click this. But if it doesn't, then if it changes again, then just close it. And then finally we start the game. So that game starts after we build the body of the GUI. And then here's the body of the GUI. I already took a look at that. Tetris icon, by the way, is generated using Glimmer GUI, using the Glimmer GUI DSL. So we've been able to generate an icon on the fly. So you can see it over here. So the GUI DSL that you use for canvas shape graphics in Glimmer could be used to build an image, a static image, not just to be used for graphics that you're seeing on the screen in the game. So that's what we did here. We built an image using the same basically canvas DSL in Glimmer. So here we basically took a bevel object. So every one of those blocks is a sort of a bevel, because it basically is a beveled kind of like 3D sort of square. So we took that and basically used it in order to build those squares over here. They're just a smaller size, and that's how we built the icon of the game. I even have like a full-fledged Glimmer Tetris project on GitHub. It's simply called Glimmer_Tetris. That basically not only builds the image randomly on start of the game, it actually, instead, what it does is it gives you a script that lets you build that image and then save it, and then from that point on you just use it going forward. So again, that's a good example of how versatile the Glimmer GUI DSL is. Not only do you use it to build screen concepts, but also static concepts that you can save in a file like an image. Anyway, so the key thing in the game is start moving tetrominos down. When that happens, it starts a thread that will follow a delay based on the model. And so it queries the game model to figure out what the delay is in order to figure out how fast the pieces should be moving. So every delay right now is like, let's just assume it's 0.1 seconds. And if the game gets harder, it becomes 0.09 and then 0.08, etc. So the delay keeps getting smaller and smaller as the game gets harder, till the game becomes too difficult and you just lose. So this is just coming from here, and given that it's in a separate thread, it could sleep without blocking the GUI. And then when it wakes up, if it's not a game over, it basically asks the game to move a piece down, unless it's paused. If it's paused, it doesn't. And that's pretty much it. That's the event loop for the game. Show high score dialog is just building a high score dialog custom widget and then showing it. And then show about dialogues, just using, so dialogues are usually useful if you want to put custom widgets within them, like any kind of arbitrary widgets within them. So here's a dialogue. I can put a table, a label, a button, whatever. Whereas message boxes are usually focused on a message. So they're different. They're less customizable and more about, okay, I just want to display a very simple message. And that's pretty much it. This is the whole game at the top level. So let's start digging down into the details of the game. Like, for example, the game, not the game model yet. We'll dig into the model layer later, but let's look at the playfield next. So what I'm gonna do is open Gladiator, which is the editor built in Glimmer DSL for SWT to do Ruby code editing. And I have it opened up where, let's see, where I open the models on top and the views at the bottom. So if you can see here in the left side in the tree, the file tree, that we have a Tetris RB entry file under the elaborate directory. So this is this file. That's the file we were just looking at. But then there's a matching directory called Tetris that has a model namespace underneath and a view namespace. And then under the view, we have the views. Under the model, we have the models. So let's start taking a look at the views. So I have playfield over here. So I'm going to maximize this just so we can look at it more easily. And so the playfield will simply receive a game playfield object that is at the model layer. So it'll receive the game playfield model. It'll receive a playfield width, a playfield height, and a block size. So that means these are the options. If I were to go back to the Tetris entry point file, when you build the playfield, these are the options that get passed here. So you can see I have a game playfield, a playfield width, a playfield height, and a block size. And this is all the information it needs to build itself. So let's take a look at the playfield again. Whoops. Okay, and then here it just builds a composite. This double buffered thing is just a useful optimization for environments other than Mac. I believe on Mac it's enabled by default, but on Windows and Linux it's not. It just improves the performance of redrawing the screen when playing the game. But then here next we have a grid layout, and the grid layout number of columns property is matching the playfield width. So that means that when you're looking at the screen here, now we're within the scope of a playfield only. And you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks horizontally. So that's basically the number of columns, because every basically one of those is a column. So we have 10 columns. So based on the number of the playfield height, which is the number of rows, we generate rows, and then we generate columns, and then basically here we build blocks. So this is another custom widget that we have in this app that's representing a Tetris single block. So one of those things is a block. One of these things is a block. By the way, those objects are called tetraminos, which is a grouping of blocks that have a certain color. We'll take a look at them next, but for now we're focusing on a block. And the block knows its own game field, and it knows the block size, meaning how many pixels you have horizontally and vertically, and then row and column. So the game is built in a way that's very customizable. I could have customized this to be a bigger screen, a smaller screen, more blocks horizontally, more blocks vertically, etc. But the configuration we have for it is the default for now. So every block will build itself, and then when you open a Ruby block under it, you basically specify the layout data, meaning extra attributes that you want to specify for it under its parent. And here we're just telling it that every block will have a width hint and a height hint that matches the block size that was passed over here in the options for this custom widget. So that's pretty much it. So, I mean, again, this is a very high level view of a playfield. All we're doing is that we have a number of rows, a number of columns, and we're filling them with blocks. That's it. And the grid layout will match the width or the number of blocks horizontally, which is 10. The rest of the options are just extra things like make column width true. What is the margin, and what are the margins if any? Horizontal spacing is 0, meaning there's no space between them, etc. But that's pretty much it. And then after that, we can dig into a block. So what is a block? So if we were to look at the block, all it is basically a canvas widget, and it has a bevel in it. That's pretty much it. The bevel color, though, is the most interesting part of this custom widget, because every block knows its own playfield, block size, row, and column. So what it does is it'll basically figure out its model, the mapping model for it. So at the model layer, we have a game playfield as well, and it's sort of a hash of rows and columns, or array of arrays, whatever it is. And basically, based on that, it'll get access to the specific block that represents this view block. And all it does is it does a unidirectional data binding into its color. So that means, and that's everything you need here. So that means this bevel custom shape object that we're using, which represents a bevel square or rectangle, is basically, it just has a base color, and based on that base color, it changes its color, something else. And all of the rest of the details are handled within the bevel custom shape object, view object, so you don't have to worry about anything else. For us at a high level, if I'm maintaining the code and I just care about how it's updating its color, that's all I need to know, is it gets its color from the matching model and from the color attribute on that matching model, and that's it. That means every time this color on that matching block changes to the model layer, it'll update the view automatically. So I don't have any code that is manually saying go to the view, go to block, let's just say block 0, 1, 2, 3 of horizontally with vertically 0, 1, 2, 3, 4, 5, go here and change this color to red. I don't have any code that says that. Instead, I have declarative code that is simply declaring that we want this view block to be unidirectionally data bound to the color of the model block that represents that exact location based on the row and column. And all of the other details are handled for me automatically. So, I mean, again, that makes the development of this game very productive, very simple, very quick to maintain. The code is very readable. So these are all advantages that you want when building business applications, especially ones that might have custom shape concepts or custom widget concepts. And the nice thing about that is also the bevel is one shape that I chose to build the game that gives it a 3D look. Like, it gives it this look as if you're looking at it a little bit from an angle. So it's a bit of a 3D look. But this bevel could have been anything. You could replace this custom shape with any shape you want. And I'll demonstrate that in a second. But let's jump into the bevel custom shapes. So a custom shape is kind of like a custom widget, except it's declared within the scope of a canvas. So it's basically a shape that will get drawn within a canvas, and it'll use a custom canvas shape, the canvas shape DSL. So it'll use declaratively, it'll use concepts like rectangle, polygon, rectangle again, etc. And for every shape, you can specify the background and foreground colors if needed. But again, I'm using unidirectional data binding, and I'm calculating based on that base color that we get. I basically, which is data bound to the model, every time it changes, all of those data binding statements will get updated automatically and declaratively without me having to do the work manually, and they will automatically calculate the color change from different parts of the bezel. Because, for example, the top part here, it gets a bit lighter than the base color. Here it gets a bit darker than the base color. Here it gets even darkest. Here it gets like a medium darkness of the base color. So based on these things, it'll basically color the different parts of the bevel shape automatically. And one thing to note about shapes also is usually you have to specify their X and Y positions, but it'll basically handle this bevel object, view object will handle all of those details. And based on that, you see things change on the screen. One thing I wanted to note is originally when I developed the game, it was a much simpler look. I did not have all of those shapes. Instead, let's just suppose I delete them and I launched the game separately over here. Basically, I did not have every single one of those details of bevel. What I had was just a rectangle. So there you go. You get a much simpler look at the game. That's how I developed it originally. So a nice thing is when you build desktop apps like that, you can prototype them very quickly like this, and then later come back and insert a custom shape like bevel. So originally I built it just like that, but then later I switched this rectangle with bevel, and that changed the look of the game. So there you go. I just restored the original code. So that's pretty much it. I mean, that's everything about the game from a high level view at the view layer. That's all we need to know. Otherwise, let's move on to the score lane. So the score lane will just contains a bunch of labels. Like the first label is what is the next piece that's coming. The next one is the score, the number of lines, and the level. And for every label, there's there's a matching basically widget afterwards that declares the information that is labeled. So the first one is actually very interesting because all we did here is reuse the playfield widget, but at a much smaller example. So remember how I was mentioning how the playfield had a width and a height, and it's customizable? We actually took advantage of that here. So we did code reuse. I passed it a different width and height. There it is. It's just 4 by 2. And here I only preview the tetramino that's coming next. So all what this does is, so instead of binding it to the main play field for the game, I'm binding it to the game preview play field. So I'm providing it as one of its options, the game preview play field. And then it data binds to the blocks from that playfield instead. So there are 2 playfields. There's the game playfield, which is the default one, and there's the game preview playfield, which is the other one, which is this tiny one on the right side. So that way I was able to reuse the code. I didn't have to code anything manually here. It worked out very nicely. But after that, we have a score, a lines, and a level, and that's just unidirectional data binding again to the game score attribute, lines attribute, and level attribute, which will get automatically updated from the model whenever changes occur, so you don't have to worry about it at the view layer. So again, the code here is as simplest as possible. This code could not get any simpler. And thanks to declarativeness, of course. Being declarative ensures a much cleaner code at the view layer. So that's pretty much it with regards to this. Let's look at the high score dialog. So the high score dialog is a custom shell, meaning it's just another window. So you can have the main window, and then you can just have another window. And this other window is nested within the main window. And it basically has a label, a table, and a button. So that's what we see here. So it's got a dialog. So the dialog class, if I'm not mistaken, extends the shell class. So when you're using a dialog widget, you're using a shell that is specialized to be nested within a parent. So you have to pass it the parent shell. And it also has a menu bar, meaning if I close this, I have a menu bar here that's showing up. When you open a dialog, it has its own menu bar, but I ended up reusing the same menu bar widget. So here, this didn't change because it basically reloaded the same menu bar. So that's just something to keep in mind. Whenever you spawn different windows or dialogues, they also have their own menu bar, but if you reuse the same exact custom widget for it, it doesn't change here. So it ends up looking very normal, like as expected by users. Though in some cases you might want to change the menu bar and have a more specific one for this exact window. But in this case, we don't really need it. So it's got a label, it's got a table. The table is doing bidirectional data binding for that game high scores. It's doing a read-only sort, meaning when I sort, I can actually sort on scores and figure out who has the highest score. But when I do so, it does not affect the model layer. It does not change the model collection. So that's just a useful feature sometimes to have a read-only sort, meaning I don't want the model collection to be updated when I sort. It's a view-only thing. It's going to be a read-only sort. And then we have a close button at the bottom. This close button, sometimes if you're at the end of the game, it'll show play again instead. If you're in the middle of the game, it's just a close button. It has the initial focus. It's just what I chose to do because that way, when you get this dialog, I can hit space and it'll close it right away because the close button has the initial focus. The rest is delegated to the game model. So here, if I hit it, it'll basically unpause the game and then restart it if it's game over. If it's not game over, it won't restart the game. It'll just, if I'm paused, if the game wasn't paused when I showed it, let me activate the game. if I show it and the game wasn't paused and then I close it, it basically remembers that it wasn't paused and it unpauses it when I close it. But if it was paused already and I show it and I close it, nothing changes. So I have all of those rules coded correctly as per the expectations of the user. Otherwise, it does a few things on initial display. So when you first display it, it does some things like saving the game paused state and checking if the game is over or not. And based on that, it does a bunch of different things. We're not going to get into those details for now, but it does things on initial display as well as on when it's closed. So when it's closed, it'll restore the paused case, the paused value of the game, as well as whether we're showing this dialogue or not. And again, it interacts with the model layer, and then we have view observers elsewhere that are observing show high scores and observing paused, and based on that, they'll alter the games. And you saw that here in the initial Tetris view. Basically, this is checking if over here in the after body, if the game over state changed, what it does, if show high scores changed, so it became false, it'll close it. So again, like we do changes at the model layer only. Usually you talk to the model, you don't talk to the view, and then the view has observers that will ensure updating itself from the model, or data binding that will ensure updating itself from the model. So let's get back here. That's pretty much one thing to keep in mind is that if I were to activate the game and go all the way to the end and lose it, some of that logic you just saw was ensuring that we were in edit mode in the table, so we automatically land on the table with a new row, and in edit mode, in case the user wanted to update their name, then they could update their name and put something like a new name here and hit enter, and when they hit enter, the focus lands here, and then they hit space and it restarts the game. So I mean, these are just things to make the app more user-friendly, and that's why there are some interactions with the SWT Glimmer DSL for SWT API for that, and you can read them on your own time. But let's move on finally to the Tetris menu bar, which is the final view concept. And here basically we have all the various menus that you saw in the game over here. So we have a game menu, a view menu, a speed menu, options menu, help menu, and under each one there are various menu items. And their states are basically, they either trigger methods on the game model, or they or for example, this will update show high score attribute on the game model, which will trigger something indirectly through data binding or view observers, either they'll do that, or they'll trigger a view level method that will spawn a dialog, like in this case, or a message box. So basically, you have a menu bar as the top, as the body root of this custom widget, and underneath, a menu bar is this entire bar, and then underneath there's a game menu, there's a view menu, an options menu, and a help menu, and a speed menu. I'm pretty sure I must have skipped it. Okay, and then underneath each one there are menu items, and then the menu items have on widget selected listeners that will get triggered when you click the menu item, and then their enablement could be data bound unidirectionally to some states on the model. You can do multiple data bindings, by the way. This is a good example of needing multiple data bindings, meaning on the game over state changes, I want the enablement to change, or on the game show high scores attribute changes, I want the enablement to change. And in order to merge values from both, you can use an on-read converter that will take the value of this and it with another value and produce the final value that will set the enablement. So that's what I'm doing for both of them. And sometimes you might want to, instead of using a converter, it might be cleaner in certain cases to use a method on the model that handles that merging of the data. And the model could be a presenter model that is a layer between the models and the view that will handle this kind of logic, or you could just keep it in a converter here. Sometimes that's convenient enough and good enough for the needs of the app. If it's a check menu item, meaning a menu item that has a check mark next to it, then in that case you can also data bind its selection bidirectionally, and it's bidirectional instead of unidirectional because I could change it by clicking one of those items. Like I can hit this and that changes the value. So usually unidirectional data binding is for view elements that will only show data from the models, kind of like a label. And then label or enablements or stuff like that. And then bidirectional data binding is when you're actually when you could actually interact with that view object and make changes. So on label, obviously I cannot change anything by clicking on a label, but on a check marked menu item, you can make a change. I can click it and it'll make a change. So that's a good example of needing bidirectional data binding instead of unidirectional. So yeah, we have various, menu items doing different things, but in the end, they all talk to the model, like game restart. This one will just close the parent proxy, which is basically the window, and it'll close the app for exit. This one is just updating this attribute when we check the menu item. And that will automatically, with bidirectional data binding, persist it to the model, which will then cause changes in other view observers, which will then display the next tetramino or hide it, the preview tetramino. This one is for showing the high scores dialog, etc. So again, by keeping the code simply focused on interacting with the model layer, the view code is very, very simple. Like I'm not having to do basically micromanagement of the view by holding its hand and like trying to build every single widget manually or build every change manually and set every attribute manually. Instead, I just data bind it to the model and I make changes in the model, and by making those changes, the view will update itself and show us new states relating to what changed in the model. Again, there's a clear high scores method on the model that we're calling here. There are various speeds that we're data binding to on the model, and we're using something called computer data binding for that one. So that means that this attribute will automatically get updated when the initial delay attribute on the model gets updated. So it's called computer data binding, which is useful sometimes. In any case, these are all examples of using data binding to data bind the menu item values to the model layer. By the way, so there are two kinds of menu items that have a check mark next to them. There's a check like a checkbox kind of menu item, kind of like this one. They call it a check menu item. There's a radio menu item. The difference is that the radio one will have an exclusive value between all of those that get selected. Meaning if I select bear, it'll deselect snail. If I select cheetah, it'll deselect bear. So that's a radio menu item. So it behaves more like a radio button, whereas this one behaves more like a check button or a checkbox. That's pretty much it. The model layer, I'm not going to dig into it in detail. The key takeaway from this tutorial is that you don't necessarily care what the model has when you're building the view. All you care about is the API. So as long as the game model has the API you need, which is how to start a game, how to declare it game over, how to rotate right, left, move right, move left, rotate right or rotate left, etc. Like as long as you support all of those methods, providing the playfield, providing the preview playfield, which is the one used in the top right corner. As long as I have all of those methods available here, then when they get invoked, I don't care what logic is invoked in them. Like somebody else could program the details of the rules of the game, and they might use AI and machine learning. But for me at the view layer, I just data bind to them, or I just do view observers of them. And when they change, I make changes in the view. Indirectly with data binding, or sometimes directly with view observers, but that's pretty much it. The rest is handled automatically by the model without me having to worry about it. So we have a game model that represents the whole game. One thing I didn't cover is that high scores are stored using a past game model that keeps track of past games. And basically it'll save them in a file on your machine locally under your user directory. So it'll make sure it's a file that it can edit. And that's how the high scores are updated over here between games. Meaning if I close the game and open it again, I'm going to see the same high scores. So this is managed here. It could have been I could have actually pushed all of those methods into past game and had it handle even the storage of the high scores. But either way, the game is the entry point of the game though, so it should still have a save high score method according to this architecture that the view talks to, and then the game can handle the details any way it wants. But that's something I didn't cover. It'll basically store them under .glimmer Tetris under user directory. Not that it matters, but it's just an extra detail that was added to the game in order to maintain scores independently of restarts. But otherwise, the fundamental thing in the game is tetrominos, and they have orientations. These are the different orientations these shapes will have when I rotate them. So that model can keep track of all the different tetrominos, their colors. These are just a shortcut representing their name, which looks it's a character, it's a letter that looks a little bit like the shape we're talking about. Like in this case, this is more of a, let's see. So if I rotate this, so this is more like an L. So this is this L, which is a dark yellow, which is exactly this shape. This one is more like a Z. So this one is called the Z shape. But either way, they're basically identified by letter names, and they have certain colors, and then they have orientations. And then this tetromino object will take care of everything relating to launching them, meaning launching them from the top into the board game or into the playfield, adding them to the playfield, removing them if needed, whether they're stopped or not, whether they're blocked on the right side or the left side, meaning if I move it to the right, now I'm blocked on the left side. If I move it to the left, now I'm blocked on the left side. So all of these details are handled at the model layer. We don't care at the view layer how they're done. Rotating them, like calculating where the blocks would land once they're rotated. And this is just me, hacking at it and taking a first attempt at doing it in the model layer. I wouldn't consider myself a game developer or an expert on Tetris necessarily, or a development of Tetris, but at the model layer, at least I'm not. At the view layer, I think I have a pretty good model of how to build it, like a pretty good view, or no pun intended, but like a good way of how to handle the view. The view layer is very simple, but the model layer, I'm not necessarily an expert on game development, but I did it one way, and as long as I matched the API that the view expects, everything worked. Of course, I might have some bugs here, but it's no big deal. They could get fixed later, or somebody could swap the model layer completely with their own model layer. That should still work. Otherwise, the tetromino is composed of blocks. Every block knows its own color, and they start with a clear color, and the clear color is when it's not filled, kind of like one of those blocks. Otherwise, it could have one of those colors that the tetrominos have. And every block will know whether it's occupied or not. So this one is clear, this one is occupied, etc. And I mean, basically, the key thing is that at the view layer, I don't care. All I care is that I have a bunch of blocks that are filling the playfield, and they will light up with different colors based on what happens in the model. So all I do is I basically data bind the color of every block cell into a corresponding model block, and then the rest happens automatically. Whenever the model changes, when, for example, the timer moves a piece down, or I hit the right button or left button or rotate, the model will make all of those calculations for me automatically, and then the view will simply, based on the use of data binding, will reflect and update its color in the shapes that changed only. So when this is moving down, only those pieces here are changing, only those blocks, so only those block colors will change. The rest will remain unchanged. So that's the nice thing about the approach of using a different widget per block is I'm using basically a canvas per block, and only the canvases that changed will update. The rest won't update, so the game will have very good performance. There's a different way of building the game, which is to have a single canvas that will render the different blocks on the single canvas. In that approach, whenever a change happens, the entire canvas will get redrawn, which will end up being slower. But by using the various like multiple canvas approach, I'll end up with much faster performance easily without having to optimize anything. However, sometimes you might want to use the single canvas. There are sometimes benefits to doing that. But in general, I mean, the benefit of a single canvas is the app will start faster because building all the different canvases, I think we have 200 if it's 10 by 20. So 200 canvases will take a while to initialize when launching the game. When you have a single canvas, I believe it'll start much faster. But other than that, when playing the game, it should have a faster performance when you're doing a single canvas per block approach. Yeah, that's pretty much it at the model layer. I think we've covered the entire game. Again, keep in mind that there's a separate Tetris Glimmer_Tetris project on GitHub that has this game encapsulated into its own app, so that way it gets packaged as a native file on Mac, Windows, or Linux. It enables packaging separately so that you can install it using an installer. So there it is. Basically, Glimmer Tetris. You can look at it after this tutorial. The nice thing about separating it into its own app, which is scaffolded Glimmer DSL for SWT, is that it gives you that Glimmer package command, which enables me to package it for the Mac so that people can download and install it. This is built for an older version of the Mac OS, so it might not work today. You'd probably have to repackage it again on your machine, but still, this is an example of how you can package it and then have users download this file and install it on their Mac for their operating system version. This one is for Windows, that's pretty much it. It has a few links for tutorials that you can read online as well in order to learn more about how to build the game. But that's pretty much it. I mean, this gives us a pretty good idea on how Tetris works now that we've introduced it at the very first Glimmer DSL for SWT tutorial. So in order to learn more about Glimmer DSL for SWT, check out the GitHub project.